In this DC circuit analysis lesson, we are going to look into series circuit and the potential divider rule. These are learner's objectives. One prominent feature of a series circuit that is useful is that the current in the series circuit is the same throughout, as you can see from the 1 ampere, 1 ampere, and 1 ampere. Okay, so it's the same. This is logical as there's only one single path where the current can flow through. Okay, so for smooth current flow, it must be the same throughout. What flows in must flow out. Or in other words, the rate of flowing in must be equal to the rate of flowing out. Let's look at a simple series circuit. To find the current, we must know the effective resistance of the circuit. So the effective resistance is to just add the resistance up. So it is 8 ohms. Once you find the effective resistance, you just use your Ohm's law and calculate the current of the circuit. In this case, 10 divided by 8 equals to 1.25 ampere. So this is the current that flows through the entire circuit. And in order to find the potential difference of each of the resistor, we make use of Ohm's law again, as now we have the value for the current in each of the resistor and the resistor value. The voltage for the red resistor will be just 1.25 multiplied by the value of 5 ohms, and the voltage for orange resistor will be 1.25 multiplied by 1, and the voltage of the blue resistor will be 1.25 multiplied by 2 equals to 2.5. From this circuit, we can see there are two interesting points. Notice that if we add up the potential difference of each of the resistor, okay, so if we add up everything, you find that the total would be 10 volts, which is the EMF of the battery. Another is to compare the ratio of the potential difference between the resistor. So we have 6.25, 1.25, and 2.5. If you do a ratio comparison, it is actually 5 to 1 to 2, which is actually the same as the resistor value. Let's see whether if we change the value of the resistor, would the results be the same. So this time around, instead of 2 ohms, we use 3 ohms. So the ratio is different. We use a different voltage and see. But we just apply the same method. Okay, 5 plus 1 plus 3, okay, in this case 9 ohms. Find the current, in this case, divide by 18 divided by 9, so you get 2 ampere. And using again since the current is 2 for each of the resistor, you just multiply by 2 times 5, so this is 10 volts. 2 times 1, which is 2 volts. Then 2 times 3 is 6 volts. So you have 10, 2, and 6. If you add up different voltage, you find that it will be still 18 volts, and the ratio of 10, 2 to 6 is still 5, 1, and 3. So as you can see from the results, the 2 points that we make would be still the same. Why is it that the ratio of potential difference and the resistance are the same? It's because the resistance, okay, the resistance are multiplied by the same factor of 2, which is the current. Since the ratio of potential difference equals to the ratio of the resistance value, it simply means that a large resistance will always have a large potential difference compared to a small resistance when they are connected in series. This is known as the potential divider rule. Just a mini recap. For a circuit with resistor connected in series, the ratio of the potential difference is equal to the ratio of the resistance. And when you add up the potential difference of the series resistor, it will give you the EMF of the battery. What's the application? Knowing these 2 points provide a shortcut to obtain the value of potential difference of resistors in a series arrangement. By knowing the values of resistors and the EMF of the battery, we can bypass the calculation of current I and obtain a potential difference of each resistors directly. The method is very similar to a type of question that you may have seen in mathematics sum problems, the distribution of candies to children based on ratio. this is using an analogy. I have a total of 70 candies to be distributed to Alice, Bob, and Charlie according to a ratio of 3, 4, and 7. So 3 is for Alice, 4 is for Bob, and 7 is for Charlie. So the question is, of course, find out how many candies each child gets. So think about it. Okay, I'm sure you should be able to solve this simple problem sum question. But if you do not know, okay, what we do is that we just add up the total number of ratio, the units 3 plus 4 plus 7. So yeah, total of 14 units. Since total number of candies is 70, divided by 14 units, so each unit will get 5 candies. And Alice have 3 units, so Alice get 5 times 3, 15. Bob get 5 times 4, 20. And Charlie get 5 times 7, 35. So why do we go through this question? Because if we see similar question of a series circuit arrangement where you have 30, 40, and 70 ohms, and your voltage is 70 volts, you find that the question is can be solved in a similar manner, where the ratio of the potential difference equals to the ratio of the resistance. So it's 3, 4, and 7. And since we know that by adding all this ratio, it will be equals to 70 volts. So the total number of units is also 14. And each unit would get 5 volts. And then you multiply by the different ratio. 5 times 3, 15. 5 times 4, 20. And 5 times 7, 35. So this question is actually very, very similar to the candies question. Okay, but maybe you're not convinced that the voltage will be this. Let's do the proper calculations. The proper calculation is, of course, we've shown you in the method, the effective resistance, you add up the effective resistance, so it's 140. Calculate the current that is flowing through over here, so it's 0.5 ampere. So, and then calculate each individual, so 0.5 multiplied by 30, 15 volts. 0.5 multiplied by 40 ohms, 20, and 0.5 multiplied by 70 ohms, 35. So using the previous method is actually a easy way to find out the voltage in a quick manner. Another application is that if you are given the ratio of the resistance and one of the potential value, you are actually able to find out the EMF of the battery and the potential difference of the other resistance. So if I know that this is 10 volts and the ratio is, let's say, 7 to 2 to 3, you're actually able to easily calculate what is the EMF and what is the different voltage. So, but since you know that if 2 units is equals to 10 volts, so 1 unit equals to 5 volts, and therefore the blue one will be just 2 times 3, 15 volts, and this is the red one will be 5 times 7, 35 volts. And of course, you can just add up 15 plus 35 plus 10 will give you 60 volts. Okay, so I hope that using this potential divider rule will help you to find to make it easier for you to analyze the circuit. That's the end of today's lesson. Please subscribe and support my channel. For my other physics video lesson arranged according to topics, please visit my blog at boringphysicsteacherswordpress.com. You can subscribe to my channel to be informed when I upload new physics video lessons. Thank you.